this study. And so that's 20 per predictor variable. So we are right there at the minimum. We can use the regular R squared. Fantastic. Let's go back to our cheat sheet here. Now there's quite a bit. Sometimes I miss some of the assumptions of regression because there are so many. The dependent variable must be scaled and should be normally distributed. We're going to set up the test, and then all of the rest of our assumptions are going to be tested through that. We're going to be looking at multicollinearity, making sure that none of our predictor variables are super correlated, meaning that we're going to be testing the same thing. We're going to be looking to make sure that it's somewhat linear in the PP plot. And then we're going to look at the residuals to make sure that they're pretty much scattered so that we have homoscedasticity. And then we'll make sure Cook's maximum value is less than 1, and then analyze the deal. That's what's up. So we have ELL, at-risk, SPED, post-test scores. But first we need to check the normality of the dependent variable, which is our outcome variable here, the boys' total post-test scores. Let's go back to this. And here we go, analyze. We're doing the normality first this time, yay. And we are not concerned with group at all because we're using everybody's data, and this is our post-test total. And this is already clicked for us because we've done that. Let's take a look. Ooh, yeah. Oh, so can't use the statistic to verify. It looks like the Smirnoff is good to go there. So let's just take a look anyway, because we have to take a look at these plots. So we've got fairly normally distributed dependent variable. I don't see any huge problems with that. We don't have anything way off in the distance, so I'm going to call that normal. You might just, in a study, I might say, this was close. So we looked at the plots, and they were mostly following along that line. And so there's that. Test of normality. I do believe that it's been met. So let's go back to this guy. So we have ELL, at-risk, and SPED, correct? That's where we're at. All right, so we go down to regression, linear. Our dependent is this post-test total score. We have several independents, which is going to be ELL, at-risk, and SPED. So we've got them right here. We go to statistics. We want all of these on the right-hand side. We actually have to, let's see, plots. We want predicted and the residuals, predicted scores, and the actual scores. For save, we want Cook's distance. For options, we don't want anything. Style, and we already had style. Okay. And then we're going to click OK. Here's our descriptives right here. Don't really mean much since these are categorical. So our correlations, we want to make sure that none of them are over 0.7 because that would indicate multicollinearity. And C and E. The highest one is at-risk status and post-test total. So as you become more at risk, your post-test score goes down. So that may come up in our model as something pretty important. So there's no 0.7 above. Here's our model summary. This is an important one. The ANOVA is significant, which means, yes, we were supposed to do this. There is some sort of slope. That's good. So here is our model. It is a significant model at 0.001 level. We have our R squared, which is 0.5 or 9. So we've got 46% of the variance in the post-test score is being explained by the 3 predictors that we thought would be important. So here is where we're going to find which ones truly were significant. So we go over to this column right here, and we see that ELL is not. At-risk status is important, and SPED status is also significant. Not as significant as the at-risk, but it is a predictor. Both of these betas here are negative, which indicates, as you are identified as at risk, your post-test score is going down. And same with if you're identified as receiving special education, it goes down. So if we think about it, it's like, wow, okay, so if you're at risk, you're doing a lot worse than if you're receiving special education services. But we have to remember that special education services come in all different forms. At risk for reading failure means at risk for reading failure. You could be receiving special education services for mathematics or something else, or behavior. So maybe that's not a great predictor, but apparently it is significant. So now we look at our part here. What we part it, we look and see, all right, so how much of the variance of how much of this 46% is being explained by these two? Again, at risk is explaining most of it. About half of the variance, or the change in the post-test score, is being explained by at risk. And 23% of the change is being explained by this special education designation. So so that's cool. Let's look down here at our Cook's distance. The maximum right here is 0.156, meaning that it's not above 1. So we're good there. The residuals are fine. Our scatter plot looks not very scattered at all. It's just a series of lines here. That, in the real world, that's not great. You really don't want to, especially after the scatter plot comes last, and you're like, oh, cool, and then bam, not so cool. Let's see. Probably say these data are not, do not meet the assumption of heteroscedasticity, of homoscedasticity, so they are heteroscedastic, and that's a limitation to present and say, this assumption was not met, so be careful of these results. The results to me make a lot of sense, but all right.
Why are the numbers okay though, but the scatter plot is not?
It's probably because we were just below the correlation for at risk. I mean, 0.7 is the line. So we kind of we were really close to that, and that may have had an influence. So we meet the assumption of multicollinearity barely, but then it has this butterfly effect on the scatter plot.
Okay. Does that have anything to do with the number of participants as well?
It could as well, because we have also the minimum number of participants where you can truly trust the data. It's good that we met everything else. If I were to find these results, if this were a particular study that I thought people would be interested in, I would certainly write up that we met all of the assumptions except the scatter plot could have been more scattered, and maybe even include this in there and say, yeah, it looks a little bit funky, but we do believe that theoretically the results make sense, and everything else, all the other assumptions were met. But of course, because we have this, there is a limitation. They're really strange. Okay. Questions. So let's see if I can actually download the write-up. This is the 2-paragraph write-up. Oh good, I downloaded it twice. So this one's really friendly. Open the file. It's open. It's just gotta open up a new MS Word. I wish there were tabs in MS Word. When are we gonna have tabs? Where you can just like the internet, where you can just tab through. Okay. So data was screened and found to meet the assumptions for linear multiple regression, except for the scatter plot. An inspection of the PP plot, the scatter plots showed that they were not homoscedastic. In addition, there was no evidence of collinearity. That's true. Between the predictor variables, because there was no correlation between those greater than 0.7, and then the Cook's distance was blank, which was less than 1, which is what we want. Multiple regression analysis was used to test if ELL, SPED, and at-risk status significantly predicted participants' overall or their post-test scores. The results of the regression indicated that the 3 predictors actually explained 45% of the variance. Then we have our R-squared right there, which is actually just going to be the 0.45, and it was significant at the 0.001 level. It was found that 2, in this case, significantly predicted the post-test, which was SPED and ELL. And then we just show the beta weights there. They'll be negative for the ones that we did. And then we explain, when we look at the parts column, we say, what kind of influence did each one have? And, ELL was, at risk was 50%, and the other one was like 23 or something. So again, you just take your project and you carefully reword it and add new numbers, which is pretty much what I do all the